go. We are in Unit 8, 8.6 to be exact, Introduction to Rational Functions, Day 1. And the first thing we're going to do is just define what a rational function is. You have this on your handout there, so go ahead and take note of the definition. A rational function is one that can be written as a quotient. Well, that's just a funny word for a fraction. And it's of the form p of x over q of x. And this is just a comma. Someone wondered what this was right here. See that right there? That's called a comma. Someone thought it was q of x squared, so I just wanted to clarify that for everyone. Tough to see from your seat. It's p of x over q of x, where p and q are polynomials. So basically, we're taking polynomials and dividing one by the other. There's one rule. There's one big rule. The denominator, q of x, can't equal what? 0, because we can't divide by 0. 1. So I handed out the graph paper for you. If you're watching at home here, grab some graph paper. There are some sites where you can print your own graph paper, in case you didn't know. They are linked on my website. You could also buy it at any of your local stores. So what I want you to do is go ahead and graph. We're going to graph 1 over x, and it looks like this. This is the parent function of a rational, and it's basically 1 divided by x. The most basic thing that the numerator could be is the number 1, and the most basic thing that the denominator could be is the letter x. And its graph looks like this. It has 2 key points for you to note. One at 1, 1, and the other at -1, -1. So go ahead and plot those points. These are kind of like the equivalent of the vertex of a parabola, or the little point at the bottom of the absolute value. And then the graph kind of just happens around it. As you move to the right, as the x's get larger, the y's get progressively smaller. Do you know what conversely means? Conversely? In an opposite way, as the x's get smaller, the y's get very large there. And it never reaches 0 in either direction. It never reaches an x value of 0, and it never reaches a y value of 0. So we have an example of the asymptote. Okay. On the other side, down in quadrant 3, the same thing happens, but in a negative fashion. As x gets more negative, y gets smaller, but never crosses 0. And as x gets closer to 0 from the left, y gets progressively bigger, but negative. So really, it's approaching negative infinity. Yes, the asymptotes would be the line y equals 0 and the line x equals 0. Those are the 2 asymptotes of the parent function. You have the horizontal asymptote is the line y equals 0. And the vertical asymptote is the line x equals 0. Remember, they're kind of the opposite of what you might think. The vertical is given by the equation x equals 0, because that's the x value that the graph appears to be like afraid of. It never wants to cross that line. So what it means then is you can never put 0 into the function for x, because what would happen if you did? You would divide by 0, which is undefined. This is an asymptote because y equals 0 will never be an output of the equation. You can't divide by something and have it equal 0. I explained that to a couple of the classes today by saying, let's take a shape. There's a pentagon. Could you take that shape, which exists right now, and divide it into 2 parts? Okay. You could take a line and you could divide it into two parts. And how big would each part be? It would each be what fraction of the original? 1/2, right? So what's one thing divided by 2? 1/2, right? Does 1/2 exist? Is it a number? Okay, all right. It's something. There's something there. What if you took that and you divided it into 3 parts? Now, they don't have to necessarily be, well, they do have to be 3 equal parts. But if you divided one thing by 3, perhaps to make this a little better, let's use a circle instead. All right. Could you take a circle and divide it into 3 equal parts? And what's 1 divided by 3? Now 1/3 still exists, right? Each little piece is 1/3. Could you take it and divide it into, like, I don't know, 8 parts? Each piece would be what fraction? 1/8. So they would still exist. Well, what if you divided it into a lot of parts, like 100? They would all exist, and each piece would be what fraction of the original? 1/100th. No matter how big the number gets that you're dividing by, is the answer still something? 1/100th. If you divided by 1,000,000, each little piece would be 1/1,000,000th. It would be very small, but never 0. Okay? So that's the graph of 1 over x. I hope you like it. And I'm done.